This video is to show you how to make an accurate quadratic graph using 5 points. I have two examples I'm going to do today. The first one is x squared minus 5x minus 24. So if I make this equation equal to 0 to do the zero product property so I can find the roots of the quadratic, which are really my x-intercepts. So if I factor this will be x minus 8 and x plus 3. So to make this equal to 0, I would have to put in 8 and negative 3. So now I have two of my 5 points, my x-intercepts. To find my y-intercept, that's simply the c value in your equation, so the negative 24. So at 0, negative 24 is my y-intercept. Now to find the vertex, what you do is you find the midpoint of your two x-intercepts because the vertex is always between those two. So to do that, what I would do is add the two x-intercepts and divide by 2. So if I do that, 8 minus 3 is going to be 5 divided by 2. So I know my vertex is 2.5. Another important thing to know is the x value of your vertex is where your line of symmetry is. So I'm just going to abbreviate. My line of symmetry is x equals 2.5. So to find the y value of your vertex, what you can do is take 2.5 and either put it in the original equation and solve it, or you can put it in the factored form. I find the factored form is much quicker. So I'm going to do 2.5 minus 8, and I'm going to do 2.5 plus 3. Well, 2.5 minus 8 is negative 5.5, and 2.5 plus 3 is 5.5. And when I multiply those two together, I'm going to get negative 30.25, which would be my y value of my vertex. So now I have 4 points. To do another point, what I like to do is reflect the y-intercept. So to reflect the y-intercept, if it's already currently at negative 24 and my line of symmetry is 2.5, so if I go to 2.5 and I reflect it another 2.5, I would be at 5. And then again, I'm just using my y-intercept to reflect that. So to show you that on the graph, if I go ahead and make a couple more dots here just to make my 8, 0 show up here. So here's 8, 0. Here's negative 3, 0. I'm counting by 3's on my y-axis, so here's negative 24. And then at my vertex, which is at 2.5, negative 30.25, so it's literally touching this line because it's so small. And then if I reflect this again, 24, if I go 2.5, if I go another 2.5, I'm going to be at 5, negative 24. And by doing that, it will have 5 points, which I can make a very accurate parabola for. And again, it goes on, it's a function, so it can go on forever. So I would just draw arrows like this. And again, if I make this a little bit darker so you can see it, you can go ahead and see that this parabola works out pretty nicely. For this next one, again, same concept. You would make this equal to 0 to do the zero product property. When I factor this, I'm going to have 2x, and I'm going to have a positive 5 here and a negative 5, a negative 3 here. So when I do the inside-outside of FOIL to check, negative 6 plus 10 would be positive 4. Negative 3 times 5 is negative 15, so that's factored form. So to make my x-intercepts or find my roots, I would try to find out what would make this equal to 0. In this case, it would be 1.5, 0. And this one would have to be negative 2.5, 0. Again, my y-intercept is my c value. In this case, it's negative 15. Again, to find the vertex, I'm going to add my two x-intercepts together. So if I add 1.5 plus negative 2.5 and divide it by 2, you can see that I'm going to get negative 1 divided by 2. So my vertex, my x value is going to be at negative half. And since we're doing this month with the line of symmetry, is going to be at x equals negative half, because remember, it's always the x value. Now I'm going to find my y value of my vertex by putting in negative half in for x in my factored form. So I'm going to go 2 times negative half minus 3. And then I'm going to go 2 times negative half plus 5. And if I do the math of this, that's going to be negative 1 minus 3 is negative 4. This is going to be negative 1 plus 5 is positive 4. When I multiply those together, my y value of the second one would be negative 16. And then again, to do another point, if I go ahead and basically take my line of symmetry, if I go to negative half, if I go another negative half, I would be at negative 1. And I'm using my y-intercept, so if my y-intercept is negative 15, I'm reflecting that. And you'll see that when I graph these 5 points now. So if I graph 1.5, 0, negative 2.5, 0, 0, negative 15, half negative, or sorry, negative half, negative 16. And if I reflect that, which is negative 1, negative 15, you can see how it exactly cuts in half here. So when I connect these 5 points, you can easily see a very accurate parabola being shown here. Oops. I made that a little bit too close there, but there's my parabola. And again, this was the one for the first example, and here's my second example.